Absolutely. Let's break down each of these physics questions with detailed explanations. Q1. Electric field and potential. Concept. In a uniform electric field, the electric potential decreases linearly in the direction of the field. Explanation. The electric field points in the positive x direction. This means the potential decreases as we move along the positive x-axis. Since B is at x equals plus 1 centimeter and A is at the origin, x equals 0, B is further along the field direction than A. Therefore, VA greater than VB. C is on the y-axis, perpendicular to the electric field. In a uniform field, points at the same perpendicular distance have the same potential. So VA equals VC. Answer B. VA greater than VB and D. VA greater than VC. Q2. Charged spheres and electric field. Concept. When conducting spheres are connected, they reach the same potential. The electric field at the surface of a sphere is related to its charge and radius. Explanation. Potential equality. V underscore 1 equals V underscore 2 equals greater than K. Q underscore 1 slash R underscore 1 equals K. Q underscore 2 by R underscore 2 equals greater than Q. Underscore 1 slash R underscore 1 equals Q. Underscore 2 by R underscore 2. Electric field at surface. E equals K. Q by R squared. Ratio of electric fields. E underscore 1 slash E underscore 2 equals K. Q underscore 1 slash R underscore 1 squared. D by R, KQ underscore 2 by R underscore 2 to the power of 2 equals Q underscore 1 slash E underscore 2. E say underscore 2. R underscore 2 to the power of 2 underscore 1 to the power of 2. Substitute Q underscore 1 slash Q underscore 2 equals R underscore 1 slash R underscore 2 from potential equality. E underscore 1 slash R underscore 2 equals R underscore 1 slash R underscore 2 and Ben Jeshil underscore 2 underscore 2 to the power of 2 by R underscore 1 squared equals R underscore 2 by R underscore 1. Answer B. R underscore 2 by R underscore 1. Q3. Magnetic field in a wire. Concept. Ampere's law helps determine the magnetic field inside and outside a current carrying wire. Explanation. Inside the wire, R less than A is to B underscore in equals mu I R 2 pi A squared. B is proportional to R. Outside the wire, R greater than A. B underscore out equals mu I 2 pi R. B is inversely proportional to R. At A2 above the surface, R equals 3A by 2. B underscore above equals mu I 2 pi 3A by 2 equals mu I 3 pi A. At A Tolman Jeshil below the surface, R equals A by 2 equals mu I B underscore below equals mu I Pendouds 2 pi A squared equals mu I 4 pi A. Ratio. B underscore above by B underscore below equals mu I 3 pi A. Ben Jeshil 4 pi A equals 4 thirds. Answer C. 4 is to 3. Q4. Diffraction. Concept. Diffraction is the bending of waves as they pass through an aperture or around an obstacle. Explanation. Diffraction is significant when the size of the obstacle or aperture is comparable to the wavelength of the wave. Both sound waves and light waves can exhibit diffraction. Sound waves have longer wavelengths, so diffraction is more easily observed in everyday situations. Light waves have much shorter wavelengths, so we typically need small apertures or obstacles to observe noticeable diffraction. Answer D. Sound waves as well as light waves. Q5. Displacement current. Concept. A changing electric field creates a displacement current, which acts like a real current. Explanation. Capacitance. C equals epsilon A by D equals 8.85 times 10 to the minus 12 F per meter, 0.001 square meters, 0.0001 meters, equals 8.85 times 10 to the minus 11 F. Displacement current, I underscore D equals C of dV by dt, equals 8.85 times 10 to the minus 11 F. 10 volts slash S, equals 8.85 times 10 to the minus 10 A. Note. There seems to be a calculation error in the provided options. The correct answer should be 8.85 times 10 to the minus 10A. Q6. LCR circuit. Concept. In a series LCR circuit at resonance, the voltage across the inductor and capacitor are equal and opposite, and the voltage across the resistor is equal to the source voltage. Explanation. Initially, VR equals V, L equals V, C equals 10V. This indicates resonance. When the capacitor is short-circuited, it's removed from the circuit. Now we have only L and R. Since the initial voltage across the inductor was 10 volts and the resistance remains the same, the voltage across the inductor will now be shared by both L and R. Without any further information, we can't determine the exact voltage across the inductor. However, if the circuit was at resonance, the voltage across the inductor would be higher than 10 volts after the capacitor is shorted. Note: the provided options seem to be incorrect or insufficient to determine the exact voltage across the inductor after the capacitor is short-circuited. Q7. Electromagnetic spectrum. Concept. Different parts of the electromagnetic spectrum are produced by different mechanisms. Explanation. Infrared. Produced by vibrations of atoms and molecules. Radio. Produced by rapid acceleration/deceleration of charges in antennas, like in klystron valves, or by electrons in aerials. Light. Produced by electronic transitions in atoms, electrons moving between energy levels. Microwave. Produced by specialized vacuum tubes, like klystron valves. Answer B. 1s, 2p, 3q, 4r.
I request all those who see this content maybe like it and subscribe. Thank you.